I attended the BCH meetups, and then I took the BSV meetups and ran that.
You forked the meetups?
Yeah, I forked the meetups. Yeah. Craig was at that one where we forked actually, and caused quite some drama.
Oh, what drama do you tell us? You like to hear about the drama.
So someone was talking about the way that...
Are you guys okay if do you want to sit closer? Do you want, when you come and sit over here? We'll sit here where Degan was sitting.
Network topology, and how it looks like a mesh network where all the peers are kind of equal. And of course that's
Eric's sitting here.
Oh, hey, that's my seat, Eric.
Go. Sorry, guys.
You got Dorsey. Yeah, so back in about 2017-18 kind of time, so they were making a presentation about the network topology and 51% attacks and how it's a mesh.
So this was a BCH meetup?
Yes.
From BTC to BCH?
It was the meetup specifically organized to form the meetups.
Because
I was on the BSV side, my friend at the time, which is more of an ultra small world network, where only the nodes connect one-to-one. So the nodes connect in a complete graph, and that means every actual miner connects to every other actual miner directly. So this mesh network that was being explained on screen is just the wrong model. That's not how it really works. Because if you have a mesh network on a P2P level, then you will start to have fragmentation where there's subsets of the nodes think this way, subsets think this that way, and that's a big waste of money because if they're all mining, then we start to get blocks that are orphaned, and that's just a waste of energy. So really the miners are incentivized to connect one-to-one because they really want to make sure that the next block is built on top of theirs. Otherwise it's a big waste of the proof of work that they did on their blocks. So, I mean, this is all ultra clear to me now. At the time, that was kind of not as clear to everyone that was in the Bitcoin meetup.
So take us back. So this is a BCH meetup, and how many people were part of that roughly at the time?
I think it was about 90.
Shortly arriving at Millbank, passengers to disembark at the back of the boat. Once again, any passengers for Millbank, please make your way to the back of the boat. Exit.
Provokes the that kind of you created a new meeting about forking the meeting.
Passengers will exit at the back of the boat.
Really, what
Passengers will exit at the back of the boat.
On exactly how large the block size could be. It was still a block size debate.
Yeah.
Because the BCH crowd thought that yes, we should slowly raise it. The BSV crowd thought there should be no limit whatsoever.
Yeah.
And that's how it's been ever since. In that, I mean, okay, there are some technical decisions that were made early on that it's difficult to go beyond 4 gigs. But at the time, we were still on, or 4 megabytes or something like that. BCH at that time, or maybe
I thought it was 8 megabytes.
Yeah,
8,
it slowly went up. Yeah. But yeah, it was mainly that, and I remember.
And was Craig Wright? Was he involved in meetings in London at the time?
You would occasionally see him, and he did show up to that fork meeting, and mostly I think to encourage people to join the BSV side, I would imagine. And so it was.
Can you guys hear okay? Great.
He pretty much immediately grabbed the mic to rebut what was on screen. He's like, that is wrong. And
so what was the controversy? Was that the controversy?
Yeah, effectively, you know how Craig is. He's not particularly tactful. And was just bluntly,
we love about him.
Bluntly honest about how wrong this individual was about the network topology, and that he didn't know what he was talking about, and that he shouldn't really be talking to all of these people trying to explain how it worked because he clearly didn't understand. So yeah.
Was that true?
Yeah, I think that was true, and I mean, I was running the meetup, and I happened to agree with Craig, and so. Yeah, I handed him the mic.
And from the 90 people you had that BCH meetup, how many remained in the forked meetup?
I don't remember the numbers off the top of my head. We actually took a spreadsheet to track that. I think it was about 60-40 to memory.
Oh, 60 people went with the BSV side?
The BSV meetup was very successful and popular at that time. We had a slight advantage in that N-Chain employees often came. So N-Chain being the company that Craig was working for at the time. Yeah. So a lot of them would come regularly. And then maybe 50% of the people who showed up would be just fintech people in Shoreditch.
Were you working at N-Chain?
No, I was working for Wright at the time, which is a B2B marketing platform. So it was my job to try and find these sort of niches and encourage them to do their live material on our platform. So yeah, that was my involvement at the time.
So obviously then there was this whole kind of return to Genesis period, wasn't there?
Yes, yep. So enabling a lot of the opcodes was that Genesis update. So that kind of enabled Xiaowei to come in.
Because the opcodes have been removed before the cigarette fork?
Not removed, it was just sort of a filter in the software that said if these opcodes are present, you're not allowed to make outputs like that. Or rather, they're disabled, they have no function. Yeah.
This
And that
is a
happened in the
safety
period
announcement.
after
Please
Satoshi.
take-
So this is a really big kind of thing that's cited in BTC, is that BTC has fixed the malleability issue.
Right.
Yeah, and that's the reason why it's superior, because it's taken out the operation codes. The operation codes we know is what makes Bitcoin Turing complete, that gives it its smart contract capability.
Yes.
So could you, is it possible to summarize the malleability issue,
think
whether
so.
it's an issue or not? Great.
I hope so. So it's the claimed issue is that you can have, just to give one example, you could sign a transaction, give it to me, and I could change something about the signature that would still be valid before I broadcast it. And what that does, because the whole transaction is hashed, is change the TX ID. So if you sent me a transaction,
Before you
you think
broadcast
you
it.
know the TX ID, but I changed something.
Oh, the
and-
recipient changes.
Yes, the
Right.
recipient or a malicious miner.
Right.
Why they would do this, I don't know. I want to receive the money from you. Why am I changing something? So the first misunderstanding from the malleability crowd is that incentives are important. There's no incentive for me to malleate a transaction that you gave
So
me.
you can't change the amount, you can't malleate the amount and say you gave me $100 worth instead of 10.
Yes.
What can you change?
Well,
Just
what I-
the transaction ID.
Just the transaction ID, effectively.
So to change the
So I could
transaction
find
ID.
a different way to result in true for any given script. And so if you have all of the opcodes, there's sometimes multiple paths to creating a script that ends in true. And that's the only thing different.
So you can't change the timestamp, you can't change the amount, you can't change the fee, so nothing significant.
Nothing significant.
Right.
It's just an inconvenience for you because you don't have the TX ID anymore. So you might have stored that transaction that you think has been broadcast, and actually I broadcast it with a different TX ID and never tell you. Why I would do that, I don't know. So there's no incentive. It would be a mild inconvenience for you rather than sort of disruptive in any other way.
Well, I've heard Wright say that malleability is a feature. Not a bug.
Yeah, so in some of the patents that Enchain wrote, they used
Now approaching Westminster Pass.
there's some malleability features that you can
Passengers
use.
will exit.
For example, in one of the locking scripts defined in one of the Enchain
Passengers will
patents,
exit at the back of the boat.
which is public, so I think I'm okay to talk about it. Check multi-sig is an opcode that checks multiple signatures against multiple public keys. There's a bug in there where it consumes one more chunk of script than all of the pub keys and signatures. And you could change the data that was in that one chunk to whatever you want. So the patent was to put token information about what that locking script represents in that one chunk. So then hypothetically you could change the data and it would change the TX ID. And so hypothetically that's a feature rather than a bug.
Right. Okay, so BTC says that it's fixing malleability by taking out the operation codes. And the operation codes aren't necessary, they're creating problematic things.
There's a list of about 10 things that they did with the goal of making transactions less malleable, let's say. Yeah.
Because it's interesting, I have the analogy that if you're doing Formula One and you want to, because obviously Bitcoin's all about competing, and Craig Wright always says, like if you don't like it, out-compete me, do better. He's always trying to stimulate or encourage people to out-compete him. What we see, I kind of relate it to a Formula One race where if you don't feel that you can out-compete your opponent, well imagine if you paid their pit stop team, and then when your opponent went into the pit stop, they started messing around and tinkering with things and saying, don't worry guys, this is very technical, you won't understand it, but we've
Talking to the FIA to
recalibrated
change
it
the rules.
to make it a little bit better. It's better now. And of course, it doesn't quite, the calibration is off and it crashes.
Right.
Like that's how I kind of see what's happening.
Well, I see that's a good analogy for the hash war, like intentional sort of destruction of the other team kind of thing.
Well, I meant more like you're tinkering with the machine of it, you know.
Yeah.
So taking out, because I say that Bitcoin is a machine, and you know, if you start tinkering with opcodes and block sizes and stuff, you're literally kind of, you know, taking a screw out here, and you're sort of messing with the actual design of the machine.
But for me, it's more like the FIA collecting the rules. So like,
Right.
so that it makes
Right.
everybody's spoilers illegal and the rules are kept, so everyone has to
Right.
look at the machines.
Interesting.
You're no longer allowed to use those, whatever, to break ducts.
So tell us what you've been doing since then.
So really, I've been working on software to try and get the SPV model, which is the model that actually scales, implemented in software. And I've tried and failed several times, and we've tried again, and I think we finally got it.
Great, so let me explain. So section 7 of the white paper, 8 of the white paper is specialized payment verification, because obviously...
Simplified, right?
Simplified
Sorry,
payment verification.
simplified payment verification. So obviously the average block time is target is 10 minutes. And so on BTC, if you send a transaction, it's going to take between anywhere from a second to like half an hour or an hour or something. Very slow and clunky, but with simplified payment verification, it enables instant transactions to be sent.
Yes.
Yeah.
But that's not obvious. It's not obvious why, I don't think. Because if you have blocks every 10 minutes,
Yeah.
and you have someone that's sending a transaction and they actually don't know when the last block is, the average time is going to be 5 minutes for that transaction to be in a block. So the question is, well, how do you prove that it's valid in the meantime, in that 5 minutes? And that's fairly sophisticated, because you need to do validation not just that transaction, but each of the parent transactions to make sure that the inputs are valid.
Well, it takes an average of 5 minutes to be resolved on the blockchain by a miner.
Yes, but only that, the tip, only the most recent transaction that I've made now. So if I give you a transaction, really what I'm doing is giving you that new transaction and the entire transaction of the parent for the input.
Yeah.
And if there are
that's the
multiple
Merkle,
inputs,
using the Merkle
that's
route.
using the Merkle paths.
Yeah. So that's how you can send a transaction to me directly, and I can verify because it have the correct Merkle
Even without
path.
internet.
Even without internet.
You can
Yes.
verify on your device, because I need to give you all of the data you need to verify for the transaction.
Yeah. So the only way that you could hack that is if you'd hacked your wallet. Is that possible? But then it wouldn't resolve to the hash wouldn't resolve to the block hash. That's the point.
So you would be able to detect that, because you would be able to tell whether or not my transaction was valid just by inspecting it. And you'd be able to tell whether the parents were valid because you have all the headers on your device.
Oh yeah. So the way that simplified payment verification works is, rather than having to run a full node with all of the information for the blockchain, all you have to do is have the headers of all of the blocks and then the information about your transactions. So if Degan was to send me a transaction, because I've already got the hashes of all of the blocks, I can verify that his transactions are within that block, because
I see a lot
I would
of
have a
fun
different
with
block
that.
hash.
Reaching embankment
I was trying to explain this to UCL students,
Once again, any
master's
passengers
students
for
yesterday, and none of them were getting
Well,
it.
these guys, all you need to have is the block headers, and then if I'm receiving the information about that one transaction, if that hash resolves to that block header, and I've got the block header, then we know it's verified. Because otherwise it'd be a different hash for the block, basically. Yeah.
So you don't need to know how plumbing works to know that plumbing is important. It is useful for everyday life, right? So SPV might be one of those things that the important takeaway is that you're actually able to validate transactions that you receive peer-to-peer, and that's how the network scales, because you can have a billion people transacting at the same time. So really.
But I was wondering if there's a way that you could hack your wallet to, no, there's no way.
I can't trick you.
You can't trick me, yeah. So I can receive the transaction before sending it to the network to get validated by a miner, and that way you still have to wait an average of 10 minutes for the transaction to get resolved on the blockchain, but I as a recipient can verify it just as I'd be able to verify a check with a check guarantee card.
Yeah, but
and then I send it to the bank later.
This also
Same thing.
changes a little bit with Terranode, which I realize it's not how things work today necessarily. With Terranode, we're going to start getting these almost like pre-validations that transaction is included in a probabilistic percentage of the miners. We're going to be building subtrees every second. So you're going to, within a second, you will have confirmation of what percentage of the miners, and it will usually be 100% of the miners, as defined by who built the last 100 blocks. That's a list of people, right? So if all of them say that your transaction is in a subtree of theirs, you know for sure it will go in the next block.
So the relevance of this is, obviously you can't scale a global monetary system if you're having to wait 10 minutes on average for a transaction to be confirmed, but with simplified verification, you can have that instantaneous transaction verification of small casual transactions, right? If you're buying a Ferrari, you still probably want to wait 10 minutes.
1 second.
But how does that prevent double spend with such a SPV?
Double spend prevention is a case of a UTXO lookup. So
that's why you have to have a transparent ledger, basically, because then everyone can see if that unspent transaction output has been previously spent. You can look that up. Is that right?
It's sort of. So that is proving the existence and the availability of UTXOs to look up. But within the period of the block construction, you don't know whether someone else has spent within the last 5 minutes. Attempted to spend.
This is a
But
safety
the miners do,
announcement.
and they reject
Please
double
take a
spend.
moment to read.
The broadcast would fail. Yeah.
And the first person to broadcast, if I broadcast
It will
first,
work.
then yours will fail.
Yes.
So is it possible to double spend in that scenario?
So it's never been possible to double spend. The question is it possible to defraud someone?
Right.
Yes, but the time period is one second. Within 1 second, the person you're defrauding will know, and you've just signed evidence against
Why
yourself.
1 second if it takes longer to send to the blockchain?
Because the UTXO lookup happens immediately.
Oh, but
when
then you do have to be
broadcast-
connected to the internet.
For that, yeah.
Oh, right, okay,
Yeah.
fine.
So double spend detection, you do have to be connected.
Right.
Exactly.
Can I ask a different question? All right. So, are you a part of the Metanet Academy? Are you a part of or aware of it?
I'm aware of it, yeah.
Okay. So,
I'm not a part of it. I'm not one of the tutors or anything like that. No.
okay. So, is that why? What is the Metanet, and why should people learn about it? In your opinion, or should they? What is your opinion on it?
I hesitate only slightly because I don't own the trademark for Metanet, but so the Metanet is let's just say it's referring to the service layer. So if you imagine the Terra nodes are in the middle, the mining network. You have the users, which are a peer-to-peer user network where we can all pay each other phone to phone, or transact phone to phone data messages as well. The service layer between can do things like provide a shared context. So one shared context might be, for example, airline tickets. So airline tickets, there's one seat on one particular physical airplane, right? You can't double spend that because no two people can sit in the same seat. So there's a good use case for this, but there are multiple airlines all trying to sell the same tickets under their brand name sometimes. So it's a good use case for a shared context globally. That would be a useful thing to have an overlay for in the service layer. That's the Metanet in some sense, in that individual user devices have all the private keys, but the sort of metadata and context of each transaction is held in this service layer. You could refer to as the Metanet.
So, and this is where the BRC 100 protocol exists. Is that right?
Yeah, so to be more specific, BRC 100 defines the interface between applications and wallets. So it's, in some sense, it's a list of, well, what things can you do as an application developer, assuming there is a BSV wallet somewhere on the user's device. And it defines that interface, and just to be as non-technical as possible, what we mean by that is it defines the function names, so like get a signature, get a public key, create a new action, abort an action that you've changed your mind about, list outputs in a particular group, that sort of thing. So BRC 100 is just a spec for that, and what that allows us to do is have wallet developers be one group of people who know everything about cryptography and key security, and then application developers who just need to focus on business needs, and just they can now assume safely anyone who's met that spec has built a secure system that their application can hook into it. And it provides us a vendor-neutral interface, which means it doesn't matter if a company goes bust, doesn't matter if there are multiple competitors, in fact, better if there weren't. And the application developers just build once, and be supported by all of the wallets in the ecosystem. That's the goal.
That's the big. So that's the breakthrough that's been brought with it. It's
Yes.
the first time that's been done.
First time that's been done. We've had multiple wallet vendors make it easier for application developers if they stick with them. But that's a problem because they might be gone tomorrow. You know, and we've had that several times with MoneyButton, RelayX, and so on. And Senti. So we can't rely on that model anymore. We need a framework that's open source. It's been backed. You know, significant investments been made into making this stuff secure and performant.
So what's the real opportunity for someone to learn that material? Can you give an example as to what would be the opportunity to not have the knowledge that you have, but to be
Get started.
Yeah.
So the quickest way to get started is fast.brc.dev. That's if you're already a full stack developer, you know what you're doing. That will get you started quickly, and you can then use those snippets to build your first app in an hour. So that's the quickest way to get started, fast.brc.dev. If you want a deep dive, and maybe you're maybe just a front-end developer that wants to learn a little bit more about how this works in depth, you can go to hub.bsv.
Now approaching Blackfriars, passengers to disembark at the front of the boat.
In-depth content.